Hello, I'm Harv Penner from Harv's Air in Steinbach, and more recently in St. Andrews as well. Something that's become important to me is as an examiner, is the testing and the abilities of people to conduct forced approaches. On both the private and the commercial flight test, exercise 22A and B is the focus here today. So part B of the flight test guide deals with the control and the approach, and part B deals with cockpit management. I'm not going to spend too much time on part A, the control and approach, although a very important item, also a very high fail item because it really involves a lot of judgment and a lot of planning for different winds and so on. The part that I want to talk about is the realism of the simulation. In other words, the forced approach and what might it look like. Most commonly on a single engine airplane, your instructor has reached over, has reduced the power to idle, and say, what are you going to do? Come up with a plan. And that's fine. That is going to continue that way. So the person is tested in their response to that situation. Can they control the airplane from the altitude they're at with the wind conditions of the day and reach the intended landing area? Now, on the way down, they must go through a series of checks to determine the cause. Well, deep down, the candidate, the pilot flying, already knows the cause. It was the simulation by the instructor. So there's the heart rate doesn't change, the intensity of the maneuver is not great because they know that at some point they're likely going to overshoot. In fact, the sooner they do that, it reduces the risk as well. So probably at 500 feet above the ground, the instructor will say, all right, you can resume normal power and climb back to altitude. I find that when I simulate a scenario where I say that you have this much power, in other words, you don't have a total power failure, you have perhaps roughness, you have some power. In fact, I'll adjust the power for them and I'll say you have 1,900 RPM in a 152. And again, often the thinking is, okay, I must land, this is a forced approach, the engine is running rough, and I have to get down. And then at some point, if it's a flight test, okay, their response is really not what I want, but that's not entirely the test. The test is to see where they're going to go. So if they're not picking up on the idea that they have partial power and they may well be able to reach a nearby airfield, at that point I'll close the throttle and so that I can test the engine out. But frequently the ability to decide whether a forced landing is even required can be a problem. So thinking of a real life engine failure, fortunately, very rare. As pilots, we hear what's going on in the industry, both in Canada and in other countries. And we know that engines aren't routinely failing, but they can. So when I just come up with a short list of what is involved in a real engine failure now, I think of things like fuel starvation. Well, that's really not an engine failure, that's a pilot failure, but we'll come back to that. Icing is a possibility, and thinking of a carbureted airplane, carbureted engine experiencing carburetor icing. There are mechanical failures, it does happen. Extremely rare, but it does happen. And some of those things might result in a partial power situation, a situation that would allow us to perhaps find a good landing area, not just landing off airport. Extremely rare, but again, it's simulated, is a fire. And again, thinking of a fire, very serious. And there's some steps to follow, of course, but if the fire is real and it's in the engine compartment, it has to be dealt with immediately. So next, I'll just talk about, what are some of the symptoms of these four areas of a power loss. So thinking of fuel, first of all, in many of the Cessnas, we operate on an on or off basis. There's not a selection of fuel tanks. So when you run out, you truly run out, but how does an engine behave when it runs out of fuel? Well, for those of you who have operated small engines in an environment where it's safe to run out of fuel, cutting your grass on your lawn, for example, you'll find that the engine may not stop. It may lose power. It may surge back to normal power, and it may do this 2 or 3 times until all the residual fuel in the fuel line and that slight amount remaining in the tank is exhausted. Well, an airplane could be the same thing. And thinking more of the airplane where selection of left or right tank is required. For example, the airplane right behind me is like that. If we allow one tank to be completely emptied, we're in a situation where if we're in cruise, or we're at a high altitude, we're gonna have time to process what's going on. If we were in the circuit and the engine lost power or some part of the circuit, i.e. even on final or on departure, would we have the time to, after a loss of power and possibly surging several times, would we have the wherewithal to say, oh yeah, I ran one tank empty? We might not. And so it's very important that, your instructor will teach you to either run a specified time per tank and then switch. And that switch shouldn't happen when you're at low altitude or just prior to takeoff, for example. So as I mentioned earlier, the failure of the engine due to fuel starvation is really a pilot failure. Why did this happen? Well, people will tell me, well, that should never happen, or that'll never happen to me. And interestingly, there can be situations where, often due to stretching our range, and then that range being affected by headwind or headwind specifically, particularly, even with the best intentions, the person may become low on fuel. So with good planning and with good decision making as this experience unfolds, we should easily be able to avoid that. So we should be able to eliminate fuel starvation, and yet reading statistics, it continues to be a thing. We have precise knowledge of our speed. In many cases, we have digital indication of our fuel burn, and yet this happens. Fuel, again, we have control of that. And just something that I stress with regard to fuel, it's common for a pilot to assess fuel levels by using a measuring stick. I will see people pre-flighting airplanes, and frequently they start that pre-flight in the cockpit and they extend the flaps. And so they exit the airplane, and on a flight test, at that point, I'll often ask, what's our fuel level? And a very common answer is, oh, I haven't dipped the tanks yet. Well, you were just in the airplane, you had the master on, you put the flaps down. Why not at that point check the fuel level? And then certainly you can dip the tanks as you've been taught, but now you have a comparison. How does my gauge indication compare with my stick measurement? Another common problem that I find is that because people don't own the airplane that they're training in, typically they pre-flight the airplane, they determine the fuel levels, they make an assessment, they fly the flight, they secure the airplane, and that's the end of their involvement with fuel. Well, if it was your own airplane, or in the future you take our airplane on a trip, then you will be the person responsible for fuel. So often the pilot has, the only knowledge they have about fuel burn is what they've read from the flight manual or what they've been told by their instructor. They just don't have that experience that they would get if they owned their airplane themselves. I'll just touch on icing for a little bit, thinking of carburetor icing. And we talk about that as well. We talk about it a great deal. In reality, though, many people have not experienced it. So where could it happen? Well, we've been taught from day one what the conditions are environmentally, temperature, humidity, and so on. So we know all that. But sometimes the indications or just the way it happens can be both subtle and just a little sneaky. And I've seen this scenario unfold where I'm flying with someone and there's a slight decrease in RPM, just very slight. And they wrongly assume that perhaps the throttle has slipped back just a little bit. So they bump the RPM back up just a little. And for the next little bit, things are fine. And if the trend continues, this may happen again, where the power is just slightly low, and they do this again. And you can see where this is going. It wouldn't take very long, and the throttle might be full open, and the power is still, say, in cruise or low cruise. Well, then something interesting happens for someone who's not thinking about icing, and just the effect that heat will have to the ice that's forming. They pull the carburetor heat control. At that point, the ice begins to melt. The engine runs rough. Someone who's not thinking carefully about what's happening may at that point say, oh, that made it even worse. They might push the carburetor heat back in again. So if ice formed to the point where RPM was decreasing, you best keep the carburetor heat on. The one area of an engine out that's percentage-wise, I don't know what the percentage is, it's fairly unlikely, but it does happen, is what I would describe as a mechanical failure. Something internally on the engine being compromised, being damaged. And in this type of a scenario, the pilot needs to make an assessment. A mechanical failure could result, as I said, in partial power. Well, partial power may get you to the airport. It could be disastrous. It could be an engine failure that results in total loss of power. With regard to this, the thing I like to mention, and I've mentioned for many years, is just in your driving experience, in your operation of other equipment other than airplanes, how many times have you operated an engine where you just, where the engine went bang and you had a catastrophic failure, a total stoppage in power? Many people will tell me, well, that's never happened to me. Well, that's great, and it's extremely rare in the case of an airplane. These mechanical, we talked about a partial loss of power. Perhaps a sense that would alert us there is simply sound or even RPM. But the sound thing I want to talk about, because any unusual sound in an airplane is going to be cause for concern. It's going to scare us. Many of us have had the experience of having a foot of our seatbelt hanging out the door. What sound is that going to make as the airplane accelerates in the air? It'll probably make a continuous tapping sound. Well, this is not normal. A fuel cap, many of the fuel caps on our high-wing airplanes are attached with a little chain. If that fuel cap isn't secured and it's resting on top of the wing attached to a chain, about the time that you start your climb out, it's going to bang on top of the cabin roof, and again, it's going to, at that moment, make you think, okay, this is what my instructor taught me about. This is that dreaded mechanical failure. But wait a minute, my other senses tell me that my airplane is performing, the RPM is normal, but I have this noise. Well, if we react correctly and take that moment to analyze, we can probably continue around the circuit, land, investigate, cutting the power on departure and doing a forced landing, because an imminent failure is predicted or likely in my mind, certainly would be a horrible reaction. And I'll continue with that in a bit, but I'll just come to the last point, which is the thing that's sometimes simulated is a fire. Well, when you think of an airplane in the sky and some part of it actually being on fire, it's probably one of the scariest scenarios that we can think of. Again, it's extremely rare, and sometimes the presence of a slight bit of smoke makes our imaginations travel really fast, and we may feel that we have a fire. The saying that where there's smoke, there's fire. So what are our senses, and what can help us analyze and make the right decision? It's often said in flying, you have seconds to make a decision that can affect or determine essentially the course of your life. So when we think of our reaction and our interpretation of some of these things, the last thing I mentioned was the fire concept. Well, on a pre-flight inspection, I rarely see someone giving a little tug to the exhaust stack on the airplane. Well, when you think of an engine fire, it would originate from the exhaust system of the airplane. We don't have access to the internal workings of the engine, or many airplanes you can't readily see the entire engine. But as an example, if you grab that exhaust stack and you felt that there was a fair bit of movement on it, well, to me that suggests that up the pipe somewhere there's a problem with that exhaust system. Thinking of the exhaust, the temperature is probably in the range of 1200 to 1400 degrees Fahrenheit. If a flame of that temperature is directed against anything combustible, bad things are going to happen. Again, extremely rare. Maintenance ensures that our exhaust system is maintained the way it should be. Going back to the engine failure, something internally failing. So again, thinking of our senses, what might we notice? What could we observe? Well, an engine needs lubrication. It needs, of course, fuel and air. The fuel and air, to some extent, we control if we monitor that. The oil level, if that oil were somehow to disappear from the engine, our senses will tell us something. Our sight picture would probably indicate that our engine parameters are not right, i.e. oil pressure decreasing, temperature increasing. How long do you monitor that before you say this is serious? Are there any other clues? Generally, if an engine truly runs hot to the point of failure, at some point you may smell something that you've never smelled, like almost like a burnt paint smell. The engine is getting extremely hot. If we do something, in this case, in the case of oil, if we do something early enough, there's a good chance that we can use that engine briefly to get us into a better landing position or into a better landing area, i.e. maybe if we hit the nearest button on our GPS function, we can get to where we need to go. Thinking of other failures, when we think failure, something has broken. Okay, obviously we have no control of that event or changing that event. Again, when I present people with this scenario, they'll do things like pull the carburetor heat on. I'll give them the example. I said, we've lost some RPM, there was a bang, and now we have vibration, but as I mentioned earlier, we have 1900 RPM. And they'll pull the carburetor heat on. Well, that's nice, but it's really probably not related. So this is maybe what we've been told to do. It's one of the things we can control, but it doesn't connect to this problem. Our senses tell us there's something mechanically wrong. So we need to make that analysis now. Do we have any power? Any power is better than no power. And so clearly we can't change this. This is our situation. And if we do have power, as I said, perhaps we can get somewhere. I mentioned senses, and I mentioned things that we have control over. We've talked about fuel. Well, we have a mixture control. We have a fuel level, which we have to ensure is correct. we have carburetor heat control, we have ignition control, and those are about the only things we have control over. When a power loss occurs and you cannot conclude, you can't determine the problem, we often use the term think outside of the box or try something. And I know of a situation firsthand, because it was one of our airplanes where the engine did lose power. The pilot made a wonderfully successful forced landing in a remote area, unfortunately. Very little damage to the airplane. And then we ended up removing the airplane, bringing it back here, and we still hadn't determined what had caused this problem. So I remember clearly starting the airplane, starting the engine, and it ran beautifully, and then it would stall. It was as if the fuel had been turned off. So I started it the second time. And the second time, I started playing with the mixture control. And as the engine came to life, it ran for probably 20 or 30 seconds, and then it would lose power. At that point, I pulled the mixture fully lean, and the engine ran beautifully until it didn't, until it ran out of fuel again. Simply by moving the mixture control back and forth, sort of contrary to what you would think. In other words, as the engine quit, I leaned it, and it came back to life. And then it ran, and then I'd push to rich, and it would run, but then it would go out again. And it developed fairly normal power. Now, by no means am I criticizing the pilot, because I had the benefit of sitting on the ground experimenting. But it kind of left an impression on me, telling me that, hey, try the unusual. Maybe there is something that you can do. So again, this wasn't catastrophic. Here was an engine that ran perfectly at one point, and then it simply lost power. No bad noises, no loss of oil pressure. Ultimately, the cause of that problem was something that was messed up in the carburetor. The float adjustment was either broken, I can't recall, or completely wrong, and it flooded the engine to the point where, or it flooded the carburetor and the engine to the point where the engine would stop. Earlier I talked about the possibility of hearing a bang in flight and then an accompanying loss of power. When I think of that situation, I think of, again, from firsthand experience, I think of a valve failure. If either the intake or the exhaust valve were to fail, then instantly that valve is going to be pounded by the piston in that cylinder. And further, that cylinder now is producing zero power. In fact, it's creating quite a drag on the engine. So there's going to be quite a lot of roughness. There's going to be a loss of power. So we're operating on 3 cylinders now as compared to 4. Again, that's not for us to determine in the air. We have no clue. All we know is what we see. We've experienced a sound. We've experienced loss of power. How much remains to be seen. I'm not saying that the engine would continue to run, but in many cases it will. And what is going to be our action? So chances are our actions in terms of remedying these kind of noises is not going to make any difference. I just want to separate those noises from noises that we've created, i.e. leaving our seatbelt out, not securing fuel caps, things of that nature. Further to our discussion on vibration, or I guess we didn't discuss vibration, but a noise perhaps. Part of the pre-flight inspection has us carefully looking at the leading edge of the propeller blades. Think for just a moment, again, extremely rare, but it does happen. Imagine that we were to lose a 2 or 3 inch section of the tip of the propeller. Think of the imbalance that would create, and it'd be pretty catastrophic. So again, we might have normal indications on our instrument panel. We have this heavy vibration. Perhaps reducing the power might make it manageable. But we can understand where losing enough of a blade would be just extremely serious, to the point where the engine could separate from the mounts. That maybe sounds too scary, right?
You know, it's good to know, because no one ever talks about this.
Because this just happened to, we had some friends, and they flew it off gravel, and they really chewed the prop. And within 20 hours, I think shortly after takeoff, they had a blade failure. And they were able to come back and land. But, it's pretty preventable. In 50 years of flying, I've never had a prop fail like that.
In the checklist there, keep the prop away from gravel and run up.
No, trust me, that hasn't stopped it. That hasn't stopped it. What stops it is the maintenance taking a file to that prop, and I hate that sound, because the blade gets progressively smaller as they file it. And unlike a boat propeller that you can weld up and build again, when these things wear down, their history. Our reaction time, as I mentioned earlier, is so vital. A quick analysis of what's going on, and then hopefully doing the right thing. I've talked about noises and strange experiences, and I think of a situation that happened here, and there may have been others, and I'm sure it's happened in other places, but I'd sent a gentleman solo in the 152. At that time, our runway was still a gravel surface, and that'll become important as I continue the story. So I was outside on the apron, and I noticed him taking off, and at an altitude of about 100 feet, the power went almost to idle. And of course, you age 10 years at that point, but it didn't take very long, and then the power came up again. And this continued throughout his circuit. The circuit never got higher than about 200 feet, and the power would alternate between high power or normal power and reduced power. And as he continued, I watched him. He was barely above the tree line, but I could see him, and he landed. And of course, you're thankful. And I called him on the radio, and he said, when I backtracked on the runway, I heard kind of a bang. And he said, I thought it was probably a stone that got kicked up from the nose wheel and hit the belly of the airplane. But to make sure that everything was in order, just before I took off, I opened the door and kind of, with the engine running, just stuck my head out and looked toward the tail surfaces of the airplane, looked underneath as much as I could, forward. Everything looked normal. Yeah, that must have been fine. And then he took off. Well, you probably know where this is going. When he closed the door the second time, he had a good chunk of seatbelt hanging out the door. So every time, as the airspeed increased, of course he's at full power on takeoff, he began to hear this noise. He was fairly mechanically inclined, so his first response was, something is wrong with the engine, so he was just experimenting. He reduced the power. Well, as he reduced the power, the slipstream noise of the slapping belt decreased. So he was pretty confident that, yeah, it's something to do with the engine. When I go to lower power, the noise goes away. Well, by the time he gets halfway through the circuit, he realizes maybe it's my seatbelt. And sure enough, it was. He landed, and as I said, I talked to him on the radio, and he tucked the belt in where it was supposed to be, and he was reasonably unfazed, and he continued in the circuit. But kind of overreacting. We're just airborne, and he reduces the power to experiment. What's happening here? Yeah, we need to make that analysis, and we need to make it pretty quick. But with good knowledge, if we know our airplane systems, I talked about vacuum and how that's not related. The suction gauge is not related to the vacuum in the intake system. So we need to know those things. Our ignition system, do we understand it? What is the failure of one mag? What does this look like? If a mag is running really rough on one side, how will that affect the overall running of the engine? So the more we can learn about those things, the more likely we are to make the right decision and hopefully not overreact or not react at all when we should be reacting.